Assalamualaikum warahmatullahi wabarakatuh. I'm Nurazia binti Mohtar. Development of Multisensing helmet for safety enhancement among motorcyclists using wireless sensor networks. The main purpose of wearing a helmet is to protect the head from direct contact in the event of an accident. Helmet also helps spread the power across the helmet and not just focus on one area. Here, it is smart helmets for motorcyclists have additional features such as sensing system, placement system, and communication systems. The smart environment always provides real-world data by sensing them or through any interface. In this design, the sensing system is realized by various sensors acting like a network. These sensors are used to send and collect details of various parameters of the working environment. The technologies of wireless sensor network (WSN) have the potential to change the way of living by many applications. A study conducted by the Malaysia Road Safety Research Institute (MIROS) found that motorcyclists contribute significantly to fatal accidents in Malaysia. Many of these fatal accidents are due to serious head injuries. This could be due to not wearing a helmet or wearing a helmet that is not approved or does not meet the safety specifications. Methodologies. This research designed a system consisting of 3 nodes and 1 web server. Sensor node in the system convert the pulse electricity from the sensor and transmit it to the WSN network through the Zigbee module. The system uses a protocol DigiMesh that allows for communication between nodes with the mesh topology that each node has homogeneity. While web server is responsible for receiving data from each node and send it to ThinkPeak. More explanation feature in the following subsections. Nodes are designed using the Raspberry Pi microcontroller as a data processor. Pressure sensor produce a pulse that is relatively straightforward with speed rotation of the rotor in the sensor. An accident can be detected through impact of pressure sensor, and as soon as it detects the accident, it will immediately send an alert SMS and location to your emergency contact. As the impact of pressure through the sensor, pulse will be generated by sensor that will then is processed by a microcontroller. Nodes can also accept command for send signal to mobile phone from web server. Web server planning. Web server act as a collector of data sent by a node over a WSN network. Web server is used as an interface between the WSN network and operator. Through web server, operator can control call signal attached to the node. Web server designed using a Raspberry Pi 4 microcontroller. The Raspberry Pi was chosen because it can be connected to the internet through a Wi-Fi dongle. Also use Raspbian operation system on Raspberry Pi allow for interface and a look, making it easier for operation to use the system. Data from the sensor node will receive Raspberry via serial USB port connected to Zigbee using the Zigbee USB device adapter. The data Raspberry receives is data has been converted into Raspberry Pi into call signal. The data will get into the graphical user interface view, deprogrammed with Python and Tkinter extensions. Result and discussion. Impact test. This test involved a series of control impact where a helmet is positioned on a metal head form and then drop in a guide fall onto various steel test anvils, which simulate different impact surface. The point chosen for impact tests are located at front, rear, crown, and either lateral, left or right. To provide information about the performance of helmet in our test, and in particular those areas where a helmet has performed well or could be considered as lacking protection, an impact zone diagram is included in each helmet data page. In each diagram, the test point has been attributed a color to show the level of performance measured against a flat surface in the high-speed test. Camera position recording. Camera position analysis and especially visual strategy analysis is one of the most important approaches in the context of performance assessment. There is a need to test the camera angle to synchronize the recording of many important aspects from the standpoint as well as the context of the road environment. Conclusion. In this paper, smart helmet to detect dangerous incident, monitor the condition of the surrounding environment and update information such as GPS location and sensor data to the center console to facilitate tracking. The system can be developed further by implementing wireless sensor network. A database can be created that monitor the sensor module continuously. In general, wireless sensor networks are defined as a type of distributed wireless network